So what is TCP or IP model? The TCP or IP model defines how devices should transmit data between them and enables communication over networks and large distances. The model represents how data is exchanged and organized over networks. So TCP/IP model helps you to determine how a specific computer should be connected to the internet and how data should be transmitted between them. It helps you to create a virtual network when multiple computer networks are connected together. The purpose of TCP or IP model is to allow communication over large distances. TCP versus IP. What is the difference? So TCP and IP are separate protocols that work together to ensure data is delivered to its intended destination within a network. IP obtains and defines the IP address of the application or device the data must be sent to. TCP is then responsible for transporting and routing data through the network architecture and ensuring it gets delivered to the destination application or device that IP has defined. In other words, the IP address is akin to a phone number assigned to a smartphone. TCP is the computer networking version of the technology used to make the smartphone ring and enable its user to talk to the person who called them. The two protocols are frequently used together and rely on each other for data to have a destination and safely reach it, which is why the process is regularly referred to as TCP or IP. So what is TCP used for? TCP enables data to be transferred between applications and devices on a network and is used in the TCP/IP model. It is designed to break down a message, such as an email, into packets of data to ensure the message reaches its destination successfully and as quickly as possible. So, importante kayo ni ang TCP labi na sa ato ang communication sa usag-usa. So, how does TCP or IP work? The TCP/IP model is the default method of data communication on the internet. It was developed by the United States Department of Defense to enable the accurate and correct transmission of data between devices. It breaks messages into packets to avoid having to resend the entire message in case it encounters a problem during transmission. Packets are automatically reassembled once they reach their destination. Every packet can take a different route between the source and the destination computer depending on whether the original route used becomes congested or unavailable. TCP or IP divides communication tasks into layers that keep the process standardized, without hardware and software providers doing the management themselves. The data packets must pass through 4 layers before they are received by the destination device. Then, TCP or IP goes through the layers in reverse order to put the message back into its original format. As a connection-based protocol, the TCP establishes and maintains a connection between applications or devices until they finish exchanging data. It determines how the original message should be broken into packets, numbers, and reassembles the packets and sends them onto other devices on the network such as routers, security gateways, and switches. then onto their destination. TCP also sends and receives packets from the network layer, handles the transmission of any dropped packets, manages flow control, and ensures all packets reach their destination. So a good example of how this works in practice is when an email is sent using SMTP from an email server. To start the process, the TCP layer in the server divides the message into packets, numbers them, and forwards them to the IP layer, which then transports each packet to the destination email server. When packets arrive, they are handed back to the TCP layer to be reassembled into the original message format and handed back to the email server, which delivers the message to a user's email inbox. TCP/IP uses a three-way handshake to establish a connection between a device and a server, which ensures multiple TCP socket connections can be transferred in both directions concurrently. Both the device and server must synchronize and acknowledge packets before communication begins. Then they can negotiate, separate, and transfer TCP socket connections. So, moto ang examples. Next, the 4 layers of the TCP/IP model. The first one is the data link layer. The data link layer defines how data should be sent, handles the physical act of sending and receiving data, and is responsible for transmitting data between applications or devices on a network. This includes defining how data should be signaled by hardware and other transmission devices on a network, such as computers, device driver, an Ethernet cable, a network interface card or NIC, or a wireless network. It is also referred to as the link layer, network access layer, network interface layer, or physical layer, and is the combination of the physical and data link layers of the Open Systems Interconnection or OSI model, which standardizes communications functions on computing and telecommunications system. So ang kaning data link layer kay mo ni siya ang mo send o kanang mga mo send or mo receive sa mga data or mo transmit sa data ngadto sa application or sa device on a network. Next, the second one is the internet layer. The internet layer is responsible for sending packets from a network and controlling their movement across a network to ensure they reach their destination. It provides the functions and procedures for transferring data sequences between applications and devices across networks. So, ang internet layer kay iya jud ning responsibilidad gyud niya nga mo send kay kanang siya may man ni siya ang mo kanang mo transfer og data ngadto sa applications og mga other nga devices adto across networks. So the third one is the transport layer. The transport layer is responsible for providing a solid and reliable data connection between the original application or device and its intended destination. This is the level where data is divided into packets and numbered to create a sequence. The transport layer then determines how much data must be sent, where it should be sent to, and at what rate. It ensures that data packets are sent without errors and in sequence and obtains the acknowledgement that the destination device has received the data packets. So from the word transport, imo siyang sige tawag na kan transport nimo sa kanang adto sa mga kanang mga reliable gani nga mga data connection sa ngadto sa mga original application or mga device nga kanang mo into intended destination ba ngadto jud sa iyang unsayang destination. So largo rin siya i-transport rin siya og largo. So the last one is the application layer. The application layer refers to programs that need TCP IP to help them communicate with each other. This is the level that users typically interact with, such as email systems and messaging platforms. It combines the session, presentation, and application layers of the OSI model. So, ang kaning application layer, mo ni siya, application app nga. Katong mag-refers ko na siya sa mga programs nga mo kanang mutabang adto para maka-communicate sa atoang usag-usa. So, next. Are your data packets private over TCP IP? So, data packets sent over TCP IP are not private, which means they can be seen or intercepted. For this reason, it is vital to avoid using public Wi-Fi networks for sending private data and to ensure information is encrypted. One way to encrypt data being shared through TCP/IP is through a virtual private network or VPN. Mao na itong gamiton kaning VPN. So next, what is my TCP/IP address? So a TCP/IP address may be required to configure a network and is most likely required in a local network. Finding a public IP address is a simple process that can be discovered using various online tools. These tools quickly detect the IP address of the device being used, along with the user's host IP address, Internet Service Provider or ISP, remote port, and the type of browser, device, and operating system they are using. So another way to discover the TCP or IP is through the administration page of router, which displays the user's current public IP address, the router's IP address, subnet mask, and other network information. So the advantages of TCP/IP protocol suite are: it is an industry standard model that can be effectively deployed in practical networking problems. It is interoperable. It allows cross-platform communications among heterogeneous networks. It is an open protocol suite. It is not owned by any particular institute and so can be used by any individual or organization. It is a scalable client-server architecture. This allows networks to be added without disrupting the current services. The last is it assigns an IP address to each computer on the network, thus making each device to be identifiable over the network. It assigns each site a domain name. It provides name and address resolution services. So mao ni ang mga advantages sa TCP/IP. Mao ni siya tanan. Then the last is the disadvantages of the TCP/IP model are: the first one is it is not generic in nature, so it fails to represent any protocol stack other than the TCP/IP suite. For example, it cannot describe the Bluetooth connection. It does not clearly separate the concepts of services, interfaces, and protocols. So, it is not suitable to describe new technologies in new networks. So, it does not distinguish between the data link and the physical layers, which has very different functionalities. The data link layer should concern with the transmission of frames. On the other hand, The physical layer should lay down the physical characteristics of transmission. A proper model should segregate the two layers. It was originally designed and implemented for wide area networks. It is not optimized for small networks like LAN or local area network. Ano mga LAN nga kan mga gagmay mga local ragod nga kan network. And PAN, personal area network, kanang atong personal nga network. Among its suite of protocols, TCP and IP were carefully designed and well implemented. Some of the other protocols were developed ad hoc and so proved to be unsuitable in long run. However, due to the popularity of the model, these protocols are being used even 30 to 40 years after introduction. So that's it. Thank you.
Let's go guys, huh?